Okay, so question 5, and now there's actually 2 definitions. So out of the, out of the, I can't even see the total. But anyway, 4 of the 15-ish marks, let me just check properly before I lie to you. 4 of the 14 are definitions. So I've said it before and I'll say it again, we really need to study our definitions. The principle of conservation of mechanical energy, it's actually kind of out of grade 10. The total mechanical energy, so we don't need to say this or part. Let me get rid of that. So the total mechanical energy, so let's get rid of all of that. The total mechanical energy in an isolated system is conserved or remains constant. You shouldn't write closed. Closed is for chemistry, so please don't even look at that. So they said for this exam, that was in 2024. I'm assuming in 2025 they're no longer going to accept that. So this definition is pretty much the same as the momentum one, except the momentum one said the total linear momentum in an isolated system is conserved. This one says the total mechanical energy in an isolated system is conserved. There's no reason why you can't know that. There's no reason why you can't know those definitions. Then for the next one, they say use energy principles to calculate the speed of the crate at point B. So let us just quickly do the numbers, because we have to do the numbers. 18 kilograms is not on here. It's 18 kilograms for the block. And it says frictionless slope. So this part has no friction. Then rough horizontal surface. So if you want to do this or something, the blue part is rough and the red part is frictionless. And point A is 3 meters above the horizontal surface. So I can see that 3 meters. And they're saying use energy principles to work out how fast the crate is going at point B. I would do the method that you used in grade 10 with the mechanical energies. And they're trying to get you to think about it by asking you that definition. So I would simply do this one. But I don't know how you guys feel. I would do this one because it's familiar to me. It's maybe not familiar to you. But how high and how fast at the top is equal to how high and how fast at the bottom. So for 3 marks, it's half mgh. So the high energy plus the fast energy at the top is equal to the high energy plus the fast energy at the bottom. Any one of those formulas will get you the mark. Sub in the numbers. So, and here again, sub-zero. Sub-zero is very important. Don't just leave stuff blank. If you know that it's 0, put a 0 there, unless you don't want that mark. If you don't want that mark, then don't bother. But if you know that something is 0, please do sub-zero, like Mortal Kombat. Sub-zero. Okay, so now we have 5 marks for this question out of 14, which is pretty good. It's about a third. So we probably already passed. Work energy theorem, another definition. So there were other options for that question. I don't think that those are the easier ones. But you can use whichever ones. I've sent you the memo, so you can go fight through those definitions if you want to. Not definitions, methods. Okay, so the work energy theorem is the net or total work done is equal to the change in the object's kinetic energy. The formula given on the formula sheet is W net equals delta EK. So there is no reason why you can't know that definition for another 2 marks. So now we have 7 out of 14 or whatever it was. So now we have 50% for the question. And this is typically the more difficult question in the exam. Then it says, using energy principles only, calculate the distance that the crate moved from B to C. Energy principles, you need to use, well, energy principles also includes work. So they want to know how far the crate traveled from B to C. We know that there is friction, but we don't know what the friction is. However, they have just told us, state the work energy theorem, which is this one. Oh, sorry. Actually, hold on, I'll just get the W net. W net equals EK. We can use that because W net is the work done by the net force. And for this blue piece, the only force acting on the block in the direction that it's moving will be friction. The only reason why it's moving forwards is because it slid down a slope. So I would say this one. I would do this one. W net is equal to the change in EK. So any one of those, and again, it looks like a bit much, and sorry if it's overwhelming, but I would go with this one. W net is equal to delta EK. So I would, sorry, not even that part, just that little blue part. So W net equals delta EK, straight off your formula sheet, done and done. Then W net is equal to, so let me just write one in between just to maybe help you a bit. It is equal to F, the force of friction, delta X cos theta. That's what's happening here. It's the force of friction. So they just wrote F. I suppose I can do that instead. The frictional force. We would like to work out the distance. 40.6 is the frictional force, which they gave you here. Sorry, see, that's a number that I missed. So 40.6, we do not put that in with a minus. We put in cos 180 to get the minus. Remember, for work energy power, it's cos of 180 if it's opposite directions, and it's cos of 0 if it's the same direction. Cos of 180 makes it negative, which means it's the opposite direction. And in this case, we know it is the opposite direction because it is friction. Friction is always in the opposite direction, so that kind of makes it easier. Friction will always be in the opposite direction to where you're moving. So if you're calculating friction using work formulas, it will always be cos of 180. So the minus 1 comes from the cos of 180, and then this 7,67 is your answer from the previous question. So this guy over here is your answer from question 5.2. So that answer, again, this is telling you how you need to try and get answers for your questions just so you can use your answers in future questions. And you see you get an answer of 13.04, and they accept anything between 13.03 and so 13.04. Then your last question is an explain question. The explain questions, I'd really like you to try and use a formula. They now say that the height of the track is lowered, so that's a height of less than 3, and you release the same crate. The distance would be smaller than. The distance would be smaller because, according to this formula, so the mgh plus half mv squared equals mgh plus half mv squared. So according to this formula, and this one is at the top and this one's at the bottom, this will be 0 at the top, you're not moving at the top, and this number would be smaller than it used to be. So that means that the mgh at the bottom is 0, so this number would be smaller than it used to be. So because the height decreased, you have less high energy, you have less energy due to your height above the earth, which means you will have less fast energy. And if you have less fast energy, your delta EK for this formula, your delta EK in this formula will be smaller, which means, and with the same friction and the same minus 1, your delta X will be smaller because the delta X and the delta EK are on opposite sides of the formula. So the delta X and the delta EK on opposite sides of the equal sign, are on opposite sides of the equal sign, so they are directly proportional. So if this number was smaller, then this number will end up being smaller. And they would have said that in a whole bunch of words. Let me just go see. So smaller than, the total mechanical energy is less, the gravitational potential energy is less, which I told you, so the velocity at B is less, so therefore the distance will be less. And that's what I said, just with using formulas. So here you didn't actually need to use a formula, but I do think it would be good practice to just always use a formula, because that's where the answers come from. It's not based on what you've experienced or what you know that happens, because I don't know whether you're aware that we're doing theoretical physics. we are doing with no air. So, most of the time. It's that one, there's that question where they ask you, what about the surface area? So if you have a block that's sliding along like this, and if I take the block and I put it on a bigger face on the ground, what difference does it make to the friction or a smaller face? It doesn't make any difference, because friction is equal to that. It's the surface times the normal, which is related to the weight. There's no surface area in this formula. And if you've ever pushed something across the ground, you would have realized that the bigger the surface area, the bigger the friction. But that's got to do with the air pressure and pressure, which when we do physics isn't a thing because we don't have any air. So try not to base your answers on what you've experienced in your life, if you can, and rather just use formulas.